Today, class, you will learn the key features of a quadratic function, which is known as a parabola. Let's explore and reason. When you're looking at a graph and you want to determine or describe what's going on, you want to look for relationships. How is the graph of f of x equal to the absolute value of x similar to the graph of f of x is equal to x squared? Well, they're similar because both graphs are drawn in the first and the second quadrant. They're also similar because the minimum point of both graphs is the origin. So they both have the origin in common. How are they different? They're different. The absolute value graph is made of two rays having the same endpoint, which is this origin right here. And those two rays are parts of a line, which is straight. But this graph right here are parts of curves. When you're looking for whether or not a graph is a function, you want to use what is known as the vertical line test. The vertical line test is a test that we use to determine whether a graph is a function. So if you look at the two red lines, these are known as vertical edges. As the vertical edges moves from the left to the right or right to the left, only one point lies on that red vertical edge, which means that this is a function. But if you look at this graph right here, now that red vertical edge is being intersected by two of the points on that graph. So this is not a function. A quadratic function can be in the form of f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers. There are certain characteristics that you want to look for when you're dealing with a graph of a parabola or a quadratic function. The first one is the vertex. The vertex is the coordinate of the maximum and the minimums. So this point right here is known as the vertex. And it is the minimum point of the graph, which means that that is the lowest that that graph can get. The axis of symmetry is the line that divides the parabola in half. This broken line right here is dividing this parabola into two equal parts. So it's dividing it in half. And the axis of symmetry is a line, and it's a vertical line. The range is the interval of y values in a function. The y value of the vertex is the lowest that it can be. But we can have any other number above that to be my y coordinate. So therefore, in this graph, the range would be the y values that are greater than or equal to -4. So every y value would be greater than or equal to -4. The domain is the interval of x values in a function. So what you have to think about is as the x value of this graph moves to the left, we're going into what is known as negative infinity. As the graph or the x value moves to the right, we're going into what is known as positive infinity. So therefore, the domain in the case of a quadratic function will be all real numbers, which means that it will be negative infinity and positive infinity. As we move on, now we want to look at another part of a quadratic function, which would be the y-intercept. The y-intercept is where the graph crosses the y-axis. So now if you notice with this graph right here, the graph is crossing the y-axis at -3. So therefore, my y-intercept would be y is equal to -3. And that is the only point that lies on the y-axis. Another characteristic would be the zeros, or another name for it would be the x-intercepts. The x-intercepts is where the graph crosses the x-axis. So this point right here and this point are known as the x-intercepts, which are the solutions to a quadratic function. And there are two solutions in this case. Another key characteristic would be what is known as whether the graph is going to open upward or downward. If my A, this number right here, is negative, then the parabola is going to open down. If the coefficient of my x squared term, which is A, is positive, then my parabola is going to open upward. So if it opens upward, there is known as a minimum point. But if it opens downward, there is a maximum point. Now, some other things that are going on with quadratic functions is whether or not they're narrow or wide. Now, we have to look at this term right here, which is my A in front of my x squared term. If A is greater than 1, we will notice that as A gets larger, greater than 1, the graph is getting more narrow. So in other words, it's a stretch away from the x-axis. This is the x-axis, and the graph is getting farther and farther away from the x-axis. But if we look at these three graphs down here, now my A, 1/2, 1/4, and 1/8 are all between 0 and 1. So A is greater than 0, but A is also less than 1, could be less than 1, which means that now the parabola is wider. So from here to here it's getting wider. It's getting wider as that number gets smaller. So we say that it's stretching towards the x-axis. Now there's one function that we really need to make sure we understand, which is the parent function of a quadratic function. It's the most simplest function in the quadratic function family. The graph of the function is a curve, and it's also called a parabola. Now, with a quadratic parent function, where this number A is equal to 1, the key characteristics are as follows. The axis of symmetry is where that line that divides the parabola into two equal parts, which is the y-axis. The range is the y-coordinate of my vertex and more. So therefore we say y is greater than or equal to 0, or we can write it in interval notation. We have a bracket that's closed, meaning that 0 is a part of my solution, and it goes on to positive infinity because it's going up. Now the domain, if we look at this same graph, the domain is all real numbers. If we look at the graph as x gets smaller and smaller, that's negative infinity, y gets larger. And right here, as x gets larger and larger, then y is also getting larger. So we say that's positive infinity. The y-intercept is where the graph crosses the y-axis. So right now we only see that the graph is crossing at the y-axis at 0. And also the x-intercept is where the graph crosses the x-axis. And here again, it's in the same place, 0. So we put those two things together, the x-intercept and the y-intercept, we have what is known as our vertex for this case. So therefore, the vertex of the parent function for a quadratic function will always be 0, 0. And it's opening upward. And the minimum and the maximum in this case, since it's opening upward, there is a minimum point. If it opens downward, then there's a maximum point. So we look at the quadratic parent function and you look at the two graphs together, notice that they are reflections of each other. They're reflecting over the x-axis. So what happens when a is greater than 0? Well, if this number right here, which is my a term, is greater than 0, then that means that the parabola is going to open up. Well, what happens if my a is less than 0? Well, this is the red graph right here. If you notice, a, it's -1 instead of +1. So there's a negative in front of that x squared term, then your parabola is going to open down. So that is the end of the lesson for today. And we are going to learn in future lessons how to find the axis of symmetry, which is a vertical line and it's known as x is equal to some number, how to find the vertex, the maximum or the minimum point, find the zeros or the x-intercepts. We're also going to find the y-intercept, and we're going to actually take those things and then sketch the graph on the coordinate plane. I hope you learned something today. If you need to look at this video more, please do so, and have a good day.